Hi everybody, I'm going to do problems 3 and 13 on the fake test that I did that does the percentiles, and I think that might help you with your actual real exam. So let's take a look. So to get the percentiles, so let's think about the normal table itself. Okay, so the normal table, you've got horizontal values on the outside, horizontal on the outside, those are on the columns, and you've got probabilities on the inside. Okay, now up to this point we've been using horizontal values. So we've been using horizontal values to find probabilities. What we're going to be doing today, when you try to get percentiles, you use probabilities to find horizontal values. So you're kind of doing what we've been up to in reverse. All right, that being said, we're going to start in the middle where the probabilities are and work out. All right, so let me draw a couple pictures. I'm going to change the slide. Okay. Let's draw some pictures. And in the first one, I want the 70th percentile. So what that means is I want 70% of the curve shaded in. And when you do percentiles, you start from left-hand side. Essentially, you're starting from negative infinity. When you draw, of course, you can't draw from negative infinity, but you start from the left and move to the right. So I want to shade in 70% of the curve. So you know, because 0 is at the 50th percentile. I'll explain that in a second when I stop drawing. Okay. I want to shade in 70% of the curve. There you go, 0.7. And I'm looking for this horizontal value where I've just drawn that sloppy X. And that's what I call K. Now, I just said a minute ago, I know it's going to be to the right of 0, because I know that 0 is at the 50th percentile. Okay, how did I know that? Well, we know that under the whole curve is probability 1. All right, that's kind of an analog from when we do discrete probability. You know, when we add up everything, it adds up to 1. The normal curve, it's continuous, and even though we don't integrate, if you were to integrate over the whole curve, it integrates to 1. Don't worry about it. I'm not going to make you do it. So I'll just draw this. Don't get frightened. If I were to integrate across this whole curve, it would integrate to 1. All right. But I also know that the normal curve is symmetric. Okay, so what does that mean? What happens is, or I should say symmetric about the mean. So the mean on the standard normal, which we're dealing with, is at 0. So what happens at 0 is what happens to the left of 0 happens to the right of 0 identically. So that means 0 is at the 50th percentile. Here's my little dotted line. So as soon as I see 70th percentile, I know that I'm going to be finding that K value, it's going to be to the right of 0. Okay? So that's what I need to do, is find K. K is missing. I have to find. All right. I'm going to draw that up real quickly again. Sorry about the atrocious handwriting. So when I'm doing this, as I mentioned before, I'm looking for 0.7, and I'm going to add a couple extra zeros because I'm looking in the middle of the table. Remember, the probabilities live in the middle of the table, and the 70th percentile is 0.7000. Okay? Now I'm going to try a little experiment here, thus guaranteeing it will fail. Let me try this. Okay, I want to bring in a file. I'm going to try to bring in part of the normal curve. And just bear with me for a moment. Got all kind of goofy stuff. Make you look at pictures of my dog. My last vacation. Hang on. We're getting close. Because it's under like normal or something equally clever. Whoop. How about normal 1A? Here we go. Alright, where'd it go? Sorry it's so small. See if I can. Ah, good. I can make it a little bigger. There. Okay, so I want to look at the closest value to 0.7. All right? So, let me just scoot this over a little more. And I'm looking in the middle here, and I see 68.59, my fault, 69.85, and 0.7109. All right? Now, you always look for the closest in absolute value. It doesn't matter if it's closest larger or closest smaller. Okay, so when I look at the 69.85, that's like 15 units off. The 70.19 is 19 units off. So I'm going to go with the 69.85, okay? So once I have that selected, I go to the left and I get 0.5. I go to the top and I get 0.02. And you just push those two together. So I'm going to have 0.5 and 0.02. So that gives me 0.52. Yes? Okay, good. Something just slid here. I'm at home. All right. So that's my K of 0.52. Got it? Got it. So then K is 0.52. All right? And then once you have that, then you throw it in that formula in the second piece. Remember, K is really a horizontal value, so it's a Z. That's what makes it okay to put it in the formula in the second piece. All right? Great. So that should take care of problem 3. 13. So on problem 13, they're looking at the upper 15th percent, but we know, I think that, wait, let me double check that. I don't have it sitting right here in front of me. Hang on. Don't go anywhere. All right, hang on. All right. So in this one, I want to make sure I tell you the right thing before I do it. Come on. I know we're looking for the 85th percentile, but I want to make sure I get the story right. And this is nice and slow. I'm pulling it up on another computer. Oh, here's a bad joke, okay, while this is scrolling up. If you have two friends named Naomi, you are what? Binomial. Actually, I think I put that in somewhere else. It's my favorite. Okay, so they're talking about the upper 15th percent. So, again, we're going to draw some pictures. Here's the upper 15th percent. Now, that's going to be, 0.15. Now, you can't get that directly. But you can, on the other hand, get 1 minus that, yes? Which is 0.85. And that's like, essentially, that's like finding the 85th percentile. And I want to get that X where that essentially cuts off the dividing line between 0.85 and 0.15. Okay, so the question that I'm trying to solve is the probability that z is less than k is equal to 0.85, or again, remember that 0.85 represents a probability, so it's going to be 0.8500, right? That helps, when you stick those extra zeros at the end, that helps you to remember it's a probability, and you have to look in the middle where the probabilities live. Always remember, horizontals go to the outside, probabilities go to the inside. It's a rule to live by. Okay, so let's go back to our Z table. Let's see if it stayed on there, if I have to load it again. Crap. I have to load it again. Sorry. I thought once you loaded it, it would stay up. That would be too simple. No dog pictures? No dog pictures, sorry. There's pictures of Spain. Want to see pictures of Spain? No? Okay. Here, loaded. All right. There it is. Okay. So I'm looking for 0.85 now. Let me scoot that down. So there's 84. So I have 8485 and then 8508. So the 8485 is 15 units off. The 8508 is 8 units off. Again, remember, it doesn't matter if it's larger, closer, or smaller, closer. You want closer in absolute value. Okay? So I'm going to pick the 8508. Yes? And I'm going to go all the way over to the left and pick up the 1.0. And then I'm going to go to the top and pick up the 0.04. So my K value is going to be 1.04. Okay? You all right with that? Good. So, whoop, sorry. Let me put that back up a little bit. So K is going to be 1.04. And that's all she wrote. Okay, are you all right with that? I'm putting this up, and it's going to take a little while, excuse me, for the movie to process, but you should have it in a few minutes. All right, thanks. What should we call this? Percentile.